Assalamu alaikum. My name is Eman Asad, and today our topic is current in electricity. Okay. Why producing electric energy? Electric energy provides us the means to transfer large quantities of energy over great distances with little loss. That's why we need electric energy in our daily life for our needs and for a lot of purposes. We need electricity. How electricity is produced? It is actually produced in the powerhouses and then transferred to our houses. And sometimes it's also produced from solar panel, and then inverter is present in our house, and it converts it into the electrical energy and then transferred to our appliances and home power. That's why we always need electricity in our daily life. It's really important. And now let's talk about if we are talking about the electricity, we need to understand the potential energy to understand the charges. Okay, potential energy. Potential energy and high potential energy increases in gravitational potential energy. What is potential energy? We know that the energy possessed by a body by its own. Okay, here they have given us the example of the potential energy and gravitational potential energy. Okay, if we do work against the gravity, the gravitational field stores that energy as gravitational potential energy. Okay, the gravitational field possesses that energy. In the same way, we are talking about the charges. We are talking about the charges. So, increase in electrical potential energy, we will work against an electrostatic force. The electric field will store that energy, and that energy will be known as the electrical potential energy. Okay, it is a configuration of charges. Like all potential energy, when it goes up, the configuration is less stable. When it goes down, the configuration is more stable. Which configuration? The configuration of the charges. And unit of electrical potential energy is joules. Okay, here they have given us example that when potential energy increases, the charges are brought into unstable configuration. Like here, stable, lower potential energy, it is stable. When we have higher potential energy, there will be instability. Q1 is going closer to the Q2, so it will require work, and that work will increase the potential energy of the charge. So, working against electric force increases electrical potential energy, like that. Working against gravitational potential was gravitational force was increasing the potential energy of gravitation. Okay. Same way it decreases potential electrical potential energy when charges are brought into more stable configurations. Okay, electrical potential energy is stored or lost as the charges. This point is really important that electrical potential energy is stored or lost as the charges. Like Q move in an electrical field and electrical field which is E. So the electrical potential energy is dependent on location of electrical field and the amount of charges moved. Okay. We have seen here higher voltage and lower voltage and the movement of the charges from higher voltage to the lower voltage. when work is done. Here, moving a charge in an electric field requires work or energy output, which is equals to the minus Q delta V. Q is the charge and V is the potential difference. Now, in circuit, what happens that from higher voltage, the charges goes towards the lower voltage, and this flow of positive charge is called the conventional current. It happens like the positive charges are moving towards the negative, like higher concentration from higher to the lower, and they keep on moving until and unless the potential difference between the A and the B, like the from higher source to the lower source, becomes zero. You can see here, to be a circuit, charges must continuously flow through a loop. Okay, what we know that what is current? Current is actually the flow of charges. The charges are flowing continuously. Then the circuit is operating and the current is flowing. But it requires an energy output. Obviously, to move the charges, we need an energy output like a charge pump that raises electrical potential of the charge. Here we can see the charge pump, and from the higher concentration it's moving towards the lower concentration, and charge pump is pumping up the charges, and then charges are flowing in the circuit and the current is maintained. And this one is the closed loop circuit in which the charges are continuously moving. Okay, we will be talking about producing the electric current. Uh, we are talking about the voltaic or galvanic cells that convert chemical energy into the electrical energy. How does it work? A battery is made up of several galvanic cells connected together. Here we can see there is a cathode and an anode. Cathode is copper is made up of copper, and it has a higher concentration of the charges, while the anode is has a lower concentration of the charges. We have a voltmeter connected here. When electric current is passed through it, the charges from higher concentration will move towards the lower, and there is a chemical present here, which is an electrolyte, which causes the flow of the charges. Photovoltaic cells are or the solar cell, which changes light energy into electrical energy, like we have seen in the solar panels. Okay, these are the basic requirements of the circuit: a cell, a bulb, a bare wire. These are the attempts to connect a circuit. In attempt A, it's not the wire is not connected to the battery. In attempt B, the wire is just connected to the positive terminal, and in C, it's not even connected to the bulb. And attempt D, it's connected to own its own, and in attempt CE, it is connected into the both the terminals. And they are the successful arrangements in which all the all the components are connected together, but in a different way. Okay, closed conducting loop is that which extends from positive to the negative terminal. There must be an energy source that maintains an electrical potential difference across the end of a circuit, like a battery or a cell. A simple definition of an electric circuit: when all the requirements of the charge of the circuit is completed, the source of the power is present, which provide the voltage, and a conducting wire is present or present, and a device is present. The circuit is completed, and charges will start to flow. Current is the flow of charges. I have told you before. And electric current is represented by I. I equals to Q upon T, where Q is the charges and T is the time. And unit of current is is ampere. 1 ampere is equals to C upon S. This is simple numerical. A 2 millimeter long cross section of wire is isolated, and 20 C of charge is determined to pass through it in 40 seconds. We will solve it by the formula I equals to Q upon T. So we will have the answer 0.5 ampere. Okay, conventional current direction. The particles that carry charge through a wire are mobile electrons which move in a direction opposite to the electric field. Here we are talking about the direction. So the direction of an electric current is by convention the direction or in which a positive charge would move, not the negative. Where positive move, we will consider that direction as the direction of the electric current. Okay, this is also a simple problem. A long wire is connected to the terminals of a battery and 5.0 seconds. 5 exponent 8 5.8 exponent 20 electron passes across section along the wire. We know that Q equals to Ne. Q is a charge equals to Ne number of electron and into the value of the electron, which is 1.6 exponent minus 19. We will multiply n number of electron with the E, which is 1.6 exponents minus 19 upon 1 electron, which is the answer of the Q would be 92.8 coulombs. Then the next step, we will apply the formula for the current, which is I equals to Q upon T, charge upon time. The charge we have find here, which is 92.8 coulomb, and the time we were given here, 5 seconds. So the answer would be 1.86 ampere current flows. If the electron flow from left to right, which direction is the current? Opposite, right to the left. Always remember that electrons flow in the opposite direction of the current. If the current is flowing from right to the left, it means that electrons are flowing from left to the right. This is also simple numerical, just like the previous one. You can see here the current is given and the time is given. We need to find the charges, and charge is equals to Q equals to Ne. We have this and we will find it. They are the circuit components. The representation of the cell, and this is the representation of the battery, and this is of wire, and this is of the light bulb, and this is of resist. This is of switch, and this is of resistor. Here we were asked to name them. This is the switch, this is the cell, and the bulb. Series circuit. How do the brightness compare? Which circuit has greater current flow? Does the charge get used up? Yes, we have seen that this is the battery and this is a bulb, and there are 3 bulbs connected in a series. This one is brighter and this one is dimmer. Why? Because the current is being distributed across the different bulbs in the series. Okay, in parallel connection, what will happen to the current? This circuit will be brighter, this bulb would be brighter, or these will be brighter. There is less current, but here there will be more current because they are connected in parallel, so we will have more current and less resistance. Okay, if one resistor is turned off, what happened to other resistors in the circuit? If we talk about that, if one resistor is removed or go out, there will be a not a closed loop for the current to flow, and all the other devices present in the series will go out. So this is an open circuit. While in parallel, if one resistance goes out, there is still a closed loop for current flow, and so the other devices in series will stay on. You can see here they are connected into the parallel. One goes out, but it's not affecting the other two. They are also lightened up, but only this one is gone. Okay, which one should be considered, series or parallel? Light bulbs are identical and have identical resistance, or which configuration produces more light? Which way do you think the headlights of a car are wired? Okay, there are two types of circuits are given, the series and parallel, and they are talking about that which one is a better option, a series or a parallel. If we have more pathways, there would be less resistance and more current, more light. So we will be considering the parallel because it has more pathways and there would be no resistance. There would be less resistance. Again, the circuit components. This is the symbol for voltmeter. This is for ammeter, and this is for ohm meter. Ammeter measures the current, so it should be always placed in series mode in the circuit. So it can easily measure the current flowing into the circuit. They don't have resistance, so they do not affect the energy of the circuit. They're just directly connected without any resistance, so they do not affect the energy of the circuit. The circuit have the same energy as it should have. Now voltmeter measures the voltage. It does not require current to pass through it. It must be placed in parallel to the circuit element. They have a lot of resistance which is actually infinite, so they do not draw current away from the circuit. If we have a lot of resistance, there will be no current flow. So they have infinite resistance. Okay, resistance. An electron traveling through wires and loads of a circuit encounters resistance. Resistance is a hindrance to the flow of charge. It means it is a hurdle in the pathway of the current flowing. It actually slows down the current, or sometimes it also stops. What does friction do? Friction stops the proper flow. Okay, so resistance also is also same like that. The amount of current in a circuit depends on potential difference and the total resistance. These are the factors that impact resistance. If you have greater length, the resistance would be more. If you have shorter length, like we have seen in the parallel circuit, that we have shorter lengths and many components of a circuit we have parallel connected, so there would be a very less resistance. But here, if you have more length, more resistance. In cross section area of thickness, more resistance is less. And type of material obviously affects the resistance. Uh, in that, if we are talking about the type of material, we will also consider the resistivity. If there would be resistivity, which is the measure of resistance of a substance, there would be obviously the more resistance. Temperature. Usually, temperature of the conductor increases, the resistance increases, but not for all substance. It varies with the different substances. These are the pictures shown of the resistors are devices that put in circuit to reduce the current. Resistors may be made up of graphite, semiconductor, or wire that are long and thin. Okay, we will talk about the Ohm's law, which gives us the proper relationship of the current, voltage, and resistance. The Ohm's law states that the current in a metal wire is proportional to the potential difference applied to its end. Like uh, this is a current; it's directly proportional to the potential difference. Current flow does not only depend on the voltage, it also depends upon the resistance. But the higher the resistance would be, the smaller the current will. V equals to IR. Here, resistance has a unit ohms and the I has the current has a unit ampere. Every element in a circuit obeys Ohm's law. Which of the following will in, will cause the current through an electric circuit to decrease? Okay. Decrease the voltage, decrease the resistance, increase the voltage, increase the resistance. We know that V equals to IR, so V is directly proportional to the I. If will cause the current to electric circuit, we will cause the current to decrease, the voltage would also be decreased. If the resistance of a circuit were triple, then the current flow through the circuit would be what? If we have current flowing here, but resistance is increasing, then the current would be one third as much. Same like that, the current will increase if the voltage is increased. Conservation of a charge in a circuit. Charges cannot be created nor destroyed, but they can be separated. The number of negative electron and positive ion in the circuit does not change. It means that charge is a conserved quantity. Okay, that's enough for today. We will discuss the other in the next class.